Hi students, my name is Veni and I am going to take chapter 3 atoms and molecules from your chemistry. Okay, so you have one chapter left, that is third chapter, atoms and molecules. Atoms and molecules. Okay, so before moving to this chapter, you have already learned in the first chapter what is matter. So what is matter? So we have already learned it in the first chapter, matter. So matter, that is when you look around, what all things you see. When you look around your room, you can see fan, chair, table, pen, pencil, book, etc. All are matter. So even when I look around, I can see my phone and I can see table, chair, pen, even this black whiteboard, everything is matter. So when you look around, what all things you see, everything is matter. So matter is anything that occupies space and which has mass or volume. Okay, so even this pen, when I keep it in a table, it occupies a space. A chair, it occupies a space. Table, it occupies a space and it has got a volume or a mass. So that is matter. Okay, so matter, you have already learned the definition of matter, that is anything which occupies space and has mass or volume is called matter. So now when moving to matter, what is matter made up of? So do you know what is matter made up of? So taking example of a matter, that is this pen is a matter. When you break this pen into smaller particles, that is, take an example, this pen, if this is a matter, when you break this pen into smaller particles, again you break it into little more smaller particles, you divide it and break it into smaller particles and reach a level when you cannot divide it further. That is, നിങ്ങൾ ഒരു മാഗ്നറ്റിക് പെന്നിനെ നിങ്ങൾ ഡിവൈഡ് ചെയ്തു, you are breaking it into smaller particles and you are reaching the smallest particle when you cannot divide it further. So that is the smallest particle of matter which you cannot divide it further. That is dividing matter into smaller particles and reaching a particle where it cannot be divided into further, and that is called an atom. Okay, so atom is the smallest entity or smallest particle of matter. So this was a new term for you, atom. You have already learned matter. That is, matter is anything that occupies space and has mass and volume. And when you divide matter into smaller particle and reach a level when you cannot divide it further, so that is atom. So what is atom? It is the smallest entity of matter. Smallest entity of matter or the smallest particle of matter. Okay, so anything around this matter, when you divide it and reach a level which you cannot divide or break it into a level which you cannot divide it further, that is the smallest particle. നിങ്ങൾ divide ചെയ്തു അല്ലെങ്കിൽ break ചെയ്തു ഏറ്റവും smallest particle എത്തിയ, that is called as atom. And this atom is the smallest particle you cannot see with our naked eyes. You can see only with the help of a microscope. Okay, so hope this is clear for you. So what is atom? It is the smallest entity of matter, and you cannot see atom with the help of a naked eye. You use a microscope. Okay, so when you look around, you see many things that is matter, and the smallest particle is atom. This much is clear for you? Okay. Now, so I have already told you, you cannot see matter with atom with the help of naked eye. You use a microscope. So for example, if you take a ball and consider that as an atom. So consider a ball as an atom. Okay, so you can consider a ball as a matter, or consider this box as a matter. So this is a matter, sorry, this as an atom. You cannot see with the naked eye, so consider this as an atom. So you got an answer. What is matter made up of? Matter is made up of atom, and atom is the smallest entity of matter or the smallest particle of matter. So this is an atom, and do you think this atom, ഈ ഒരു atom ഒറ്റയ്ക്ക്, ഇത് smallest particle ആണ് വിചാരിച്ചു, ഈ ഒരു atom ഒറ്റയ്ക്ക്, so you have broken this matter. ഈ matterനെ നമ്മൾ smaller pen as a matter, ഈ matterനെ നമ്മൾ smaller particles ആയിട്ട് break ചെയ്തു, you got the smallest particle as atom, and consider this as the atom of this matter. Matter ഈ പെന്നും atom ഇതായിട്ടും. So do you think ഈ ഒരു atom ഒറ്റയ്ക്ക് you can make it, reverse it and make this a pen? ഒറ്റയ്ക്ക് ഈ ഒരു ആറ്റത്തിനെ റിവേഴ്സ് ചെയ്ത് പെന്നാക്കാൻ പറ്റുമോ? No, this atom, this smallest particle of matter, which is called as atom, combines with another atom. This combines with, consider this as an atom and this is an atom. This atom combines with another atom. Okay, so when atom combines with another atom in definite proportion, so it has got definite proportion. That is the correct proportion. One atom, where an atom will combine to form molecule. So what is molecule? Atom combines with another atom in definite proportion. Atom combines with, this is an atom, this is an atom, this combines with another atom in definite proportion and form molecules. Okay, so now we have got an idea what is atom and what is molecule. So atom is the smallest entity or smallest particle of matter, and atom combines with another atom in definite proportion, in definite ratio, correct proportion. That is called as molecule. So this is an introduction of atom and molecule. So in your textbook as an introduction that is given history of atom and molecules. So in that all philosophers atoms ne patti molecules ne patti parayunna all philosophers name and introduction at history koduttundu. So just read it and you can understand what it is. Okay. An exam point of view that is not much important, but read it and understand that as a history of atom and molecule. Okay, so in your textbook it is given in first as an introduction. Okay, now so moving to the details of atoms and molecules, you will learn it in the next class, but now keep in mind what is atom and molecule, and now we'll move to the next topic of this chapter. Okay, so what is atom, what is molecule, and what is matter is clear now. Okay, what is atom? It is the smallest entity of matter. If this pen is a matter, and if you are dividing or breaking this pen into smaller particles, and the smaller particle is called atom, which you cannot see with the naked eye. So this is an atom, and this atom combines with another atom in definite proportion, which is called as molecule. Okay, so hope this is clear, this much is clear. Now the next topic in your textbook is law of conservation of mass. So some laws you are going to learn, that is how this atom combines with another atom. Enganana atom where atom definite proportion combine cheyyunnathu ayinde oru law aanu പഠിക്കാൻ പോകുന്നത്. Okay, so law of conservation of mass, that is the next topic you are going to learn. Okay, so atoms and molecules in detail you will learn in the next class, but now as in your textbook, the topic given, next topic is given as law of chemical combination, and you have two laws, law of conservation of mass and law of definite proportion. Okay, so two laws that is given. Okay, so law of chemical combination or enganana combine cheyyunnathu atoms, angane law of chemical combination adathu rendu laws padikkanundu, law of conservation of mass and law of definite proportion. Okay, so now you will learn only the first one today, law of conservation of mass. The next law you will learn it in the next class. Okay, so now we will move to the law. Okay, now we are moving to the next topic, that is law of chemical combination, and there are two laws. I have already told you atoms combine in definite proportion to form molecules. So you are going to study the law of chemical combination. In that two laws are there. First one is law of conservation of mass, and second one is law of constant proportion. So law of constant proportion we will learn it in the next class. Today we are going to learn of law of conservation of mass, and this law was proposed by Anton Lavoisier. Okay, so in the textbook Lavoisier is given. So its full name is Antoine Lavoisier. So he proposed law of conservation of mass, and according to this law, the law states that mass can neither be created nor be destroyed in a chemical reaction. In a chemical reaction, the mass can neither be created, mass create cheyan pattilla, nor the mass cannot be destroyed. So this is the law of conservation of mass. So law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. So what is a chemical reaction? So for example, if you are taking two glass, so you are taking salt and you are taking water in a glass and you are mixing it. Okay, salt and water, and you are mixing it, and you will get a combination of salt and water. Is this a chemical reaction? Salt to vellam mix it, you will get a product, that mixture, that is salt and water. Is this a chemical reaction? No, this is not a chemical reaction, because you are adding salt and water and you are getting a product which is salt and water. No new products are formed. But in a chemical reaction, when you take, for example, you are adding acid, You are adding any acid, so you can take any acid. So you know what is acid and all. You are adding acid plus any base you are taking. Okay, acid plus base, and you will get a product which is salt water. So you are adding acid base into a test tube and you are getting a product which is called as salt water. So you are adding salt and base and you are getting a salt water. ഏതെങ്കിലും ഒരു ആസിഡും ഏതെങ്കിലും ഒരു ബേസ് ആഡ് ചെയ്യുമ്പോൾ നമുക്ക് സോൾട്ട് വാട്ടർ കിട്ടുമ്പോൾ ഹിയർ യു ആർ ആഡിങ് ടു റിയാക്ടൻസ് ആൻഡ് യു ആർ ഗെറ്റിംഗ് എ ന്യൂ പ്രോഡക്റ്റ്. ദിസ് ഇസ് എ കെമിക്കൽ റിയാക്ഷൻ. So what all things you are adding, it is called as reactants and the result is called as product. So when reactants here react to form a product, it is called as chemical reaction. Reactants, അതായത് ആരോടെ മെയിനുള്ള റിയാക്ടൻസും ആരോ കയ്യിൽ നമുക്ക് കിട്ടുന്ന പ്രോഡക്റ്റ്, that is product. So when new product are formed, that is called as a chemical reaction. You know chemical reactions and you have studied many chemical reactions, is it? So in that chemical reaction, that is A plus B combined to form a product C. That is A plus B is the reactants and C is the product. So this is called as chemical reaction. So in a chemical reaction, mass can neither be created nor be destroyed. That is, for example, in this example itself you can take, you are adding acid and base, you are getting salt water. So you are adding acid and base, the mass you can take, for example, it is 5 gram. I am assuming the mass of acid and base you are adding is 5 gram, and acid and base are the reactants, and the chemical reaction takes place and a product is formed. The product formed salt water. When you measure, the salt water is only also having 5 gram, same gram. Okay, that is mass before the reactions and after the reaction is same. This is mass can neither be created nor be destroyed in a chemical reaction. This product is 5 gram, 5 gram കൂടുതൽ 6 gram ആവുകയോ അതിന് കുറവ് 4 gram ആവുകയോ ചെയ്യുന്നില്ല. Because mass can neither be created, it cannot be created extra വരുവോ അല്ലെങ്കിൽ അതിനകത്തുള്ള മാസ് പോവോ ഡിസ്ട്രോയ് ആവുകയോ ചെയ്യുന്നില്ല. That is called as that is the first law of conservation of mass. Mass is conserved. Mass അവിടെ conserve ചെയ്ത് വെക്കുക. You know what is conserved? It is not destroyed nor it is formed. It is already conserved. That is law of conservation of mass by Anton Lavoisier. Mass can neither be created nor be destroyed in a chemical reaction. So hope this is clear for you. What is chemical reaction? What is chemical reaction? Reactants combine to form a new product. So when reactants combine to form a product in a chemical reaction, the mass of the reactants and product will be equal. That is, it will not be increased or it will not be decreased. So you have to study this as such. You should not write in your own words. ഈ ഒരു തിയറി അല്ലെങ്കിൽ ലോസ് ഒക്കെ നിങ്ങളുടെ വേർഡ്സിൽ എഴുതാൻ പറ്റില്ല. സ്റ്റഡി ആസ് സച്ച്. മാസ് ക്യാൻ neither be created nor be destroyed in a chemical reaction. ഒരു ടേമോ ഒരു വേർഡോ പോലും അങ്ങോട്ടും ഇങ്ങോട്ടും മാറാതെ as such you have to study. So what is law of conservation of mass by Anton Lavoisier? Mass can neither be created nor be destroyed in a chemical reaction. So and experiment is given in your textbook which was conducted. So we will deal with the experiment and we will further understand what is this. Okay, so after this experiment you will be thorough with law of conservation of mass or how this law is proved. Okay, so experiment is given in your textbook as the first experiment. We'll deal with that and we'll conclude. Okay, so this is the experiment. So here in this experiment a conical flask. So there is a conical flask and in that conical flask you are keeping a test tube. And you are tying it with a thread. So you are tying the test tube with a thread and placing a cork. ഒരു അടപ്പ് വെച്ച് ടൈറ്റ് ആയിട്ട് ത്രെഡ് ടെസ്റ്റ് ട്യൂബിന്റെ ത്രെഡ് ഇങ്ങനെ ടൈറ്റ് ആയിട്ട് അടച്ചു വെക്കുക. So this is the experiment setup. So you are taking a conical flask and you are keeping a test tube and you are tying it with a thread and you are placing a cork and tightening it. Okay, so in your textbook experiment is clearly explained and there are two solutions X and Y. So X നിങ്ങൾക്ക് കുറേ തന്നിട്ടുണ്ട്, copper sulfate, lead nitrate, barium chloride, and Y such a 3 or 4 reactions are given there. എന്ത് വേണമെങ്കിലും നിങ്ങൾക്ക് ആഡ് ചെയ്യാവുന്നത്. So here I am taking and I am explaining it one setup, that is inside the test tube. Inside the test tube you are adding copper sulfate. So test tube the copper sulfate and in the conical flask you are adding sodium carbonate. So everything is tightly set up, that is conical flask sodium carbonate ടെസ്റ്റ് ട്യൂബിൽ കോപ്പർ സൾഫേറ്റ് ആഡ് ചെയ്യുക. ഇതിങ്ങനെ ടൈറ്റ് ആയിട്ട് വെക്കുന്നുണ്ട്, അത് മിക്സ് മിക്സ് ആവുന്നില്ല. ഓക്കെ, സോ ഫസ്റ്റ് കണ്ടീഷൻ ഇസ് ഇറ്റ് ഇസ് നോട്ട് മിക്സ്ഡ്, ദാറ്റ് ഇസ് copper sulfate and sodium carbonate. And in your textbook the given weight is 5% of copper sulfate and 5% of sodium carbonate. What is 5%? That is, you are taking 5 gram of copper sulfate, you are taking 5 gram of copper sulfate and you are mixing it 100 ml of water. Okay, in 100 ml of water. 5 gram of copper sulfate എടുത്ത് 100 ml of water mix ചെയ്യുമ്പോൾ you will get 5%. So 5% എടുക്കുന്ന textbook experiment setup ആണ്. Okay, so you are taking 5% of copper sulfate. What is 5%? You are taking 5 gram of copper sulfate and mixing it 100 ml of water. And that copper sulfate you are adding inside the test tube. And then you are taking say 5% of sodium carbonate, that is 5 gram of sodium carbonate in 100 ml of water, and you are adding it into the conical flask. And you are tying a thread and you are tightening it with the help of a cork, so that ഇങ്ങനെ ടൈറ്റ് ചെയ്ത് വെക്കുന്നതുകൊണ്ട് ടെസ്റ്റ് ട്യൂബിൻ്റെ അകത്തെ മിക്സ്ഡ് ടെസ്റ്റ് ട്യൂബിൻ്റെ അകത്തെ സൊല്യൂഷൻ കോണിക്കൽ ഫ്ലാസ്കിൻ്റെ സൊല്യൂഷൻ ദാറ്റ് വിൽ നോട്ട് ഗെറ്റ് mixed. Okay, so this is the experiment setup. You are taking a conical flask and you are adding 5% sodium carbonate, and inside the conical flask you are keeping a test tube and you are tying it to the thread and keeping a tight cork in and making the setup tight. Okay, and inside the test tube you are adding 5% of copper sulfate. So in your textbook it is given X and Y. So X and Y, many solutions are given there: copper sulfate, barium chloride, lead nitrate. So anything you can take. So I am doing this experiment and I am teaching this experiment with the help of copper sulfate and sodium carbonate. So this is the experiment setup, and next step what you have to do is you have to slightly loose the cork. So when you loose the cork, what happens? Thread balance will lose down, and what happens is the solution inside this test tube get mixed with the solution outside in the conical flask. So when you lose the cork, what happens? The solution, the content gets, first thing the content doesn't mix. Why? Because the test tube is already fixed with a thread and it is tightly kept there. When you use the cork is like that using, but thread we lose it, what happens? The test tube, the solution inside the test tube get mixed with the solution of the conical flask, and what happens? It precipitates and a reaction takes place. That's it. Reactions, normally reaction takes place. So what was the reactants? Copper sulfate plus sodium carbonate. This is the reactant. Is it? This is the reactant, copper sulfate and sodium carbonate. This is the experiment setup. This is the reactant before the chemical reaction takes place. Okay, so these are the reactant, and when you lose the test tube, the thread loose ചെയ്ത് cork loose ആവുമ്പോഴത്തേക്കും ഇതിൻ്റെ അകത്തുനിന്നുള്ള സൊല്യൂഷൻസ് വന്ന് ഇതുമായിട്ട് റിയാക്ട് ചെയ്ത് ഇവിടെ ഒരു പുതിയ പ്രോഡക്റ്റ് ഫോം ചെയ്യും. പ്രോഡക്റ്റ് ഇസ് ഫോംഡ്. വാട്ട് ഇസ് ദി പ്രോഡക്റ്റ് ഫോം വെൻ കോപ്പർ സൾഫേറ്റ് ആൻഡ് സോഡിയം കാർബണേറ്റ് റിയാക്ട്സ്? സോ ഇത് തമ്മിൽ ഇതിൻ്റെ സൊല്യൂഷൻസ് ഇതിൻ്റെ അകത്തോട്ട് മിക്സ് ചെയ്യുമ്പോൾ നോർമലി അവർ കെമിക്കൽ റിയാക്ഷൻ നടക്കും. റിയാക്ഷൻ നടന്ന് ഫോം ചെയ്യുകയാണ് കോപ്പർ കാർബണേറ്റ് plus sodium sulfate. പുതിയ റിയാക്ഷൻസ് നടന്നിട്ട് അത് വന്ന് താഴെ വന്ന് precipitate ചെയ്യും. So this is the reactant and this is the product. So now one more thing was there. When you have to weigh this, അതായത് നമ്മുടെ ഫസ്റ്റ് സെറ്റപ്പിൽ വരുമ്പോഴത്തേക്കും, അതായത് നമ്മൾ ടെസ്റ്റ് ട്യൂബിൻ്റെ അകത്ത് സൊല്യൂഷൻ ആഡ് ചെയ്ത് കോർക്ക് വെച്ച് ടൈറ്റ് ചെയ്യുമ്പോൾ you will weigh. You have to weigh it with a weighing machine. You will take the weight. Let that be x. Okay, x gram ആയിരിക്കട്ടെ. നമ്മൾ വെയിറ്റ് എടുക്കും, വെയിങ് മെഷീൻ വെച്ചിട്ട് ആ കോണിക്കൽ ഫ്ലാസ്കിൻ്റെ വെയിറ്റ് എടുക്കും. അപ്പോൾ റിയാക്ഷൻസ് ഒന്നും നടന്നിട്ടില്ല. കോപ്പർ സൾഫേറ്റും സോഡിയം കാർബണേറ്റും നമ്മൾ ഒഴിച്ച ടെസ്റ്റ് ട്യൂബിൻ്റെ അകത്തും കോണിക്കൽ ഫ്ലാസ്കിലും അതേപോലെ വെച്ചിട്ട് നമ്മൾ വെയിറ്റ് എടുക്കും. ദാറ്റ് ഇസ് x gram. ആൻഡ് നമ്മൾ ടൈറ്റ് ചെയ്ത് വെച്ചിരിക്കുക. അതിന് നെക്സ്റ്റ് സ്റ്റെപ്പ് ഇസ് വി വിൽ ലൂസ് ദി കോർക്ക്, ആൻഡ് വാട്ട് ഹാപ്പൻസ്? ദി സൊല്യൂഷൻ ഇൻസൈഡ് ദി ടെസ്റ്റ് ട്യൂബ് will react with the solution of the conical flask. It will fall into the conical flask and reaction takes place, and reaction നടന്നു കഴിയുമ്പോൾ you will weigh it once again. When you weigh it again, you will get the same x gram. X gram എന്തെങ്കിലും ആയിക്കോട്ടെ, if it is 20-25 gram, after the reaction also you will get the same 25 gram or the x gram. Whatever the weight be, same തന്നെ ആയിരിക്കും പ്രോഡക്റ്റ് നമ്മൾ റിയാക്ഷൻ നടന്നു കഴിയുമ്പോൾ കിട്ടുന്നത്. So from this experiment it is proved that in a chemical reaction mass can neither be created nor be destroyed. Even before the chemical reaction the weight was x gram. After the chemical reaction when product is formed same x gram than product in the weight. So this clearly explains what the law of conservation of mass, that is mass can neither be created nor be destroyed in a chemical reaction. Okay, so read this experiment in your textbook, and you have to read the introduction part which is given in your textbook about some philosophers and what they tell about atoms and molecules. Okay, some philosophers names are given there which may be difficult for you, but just read it and understand. But study this experiment clearly and understand how Anton Lavoisier proved that mass can neither be created nor be destroyed in a chemical reaction. So with this we are winding up the class. So today we have learned what is matter. Matter is anything which occupies space and has mass or volume is called as matter, and when you divide the matter and when you reach a stage when that particle it cannot be further divided, and that is atom. So atom is the smallest entity of matter. An atom combines with another atom in a definite proportion, that is called as molecule. And we have learned the one law of chemical combination. Two laws are there, law of conservation of mass and law of constant proportion or law of definite proportion. Second one you will learn it in the next class. First one is law of conservation of mass by Anton Lavoisier, that is mass can neither be created nor be destroyed in a chemical reaction. Okay, this is the experiment setup. So read the textbook thoroughly and understand. So we'll meet in the next class. Thank you.